Okay, I think we can start right now. So hello once again. My name is Bartek Tadla. I'm head of business development at Silvair. And together with Paweł Śmietanka, who is head of UX, we will be driving today's session about in-node scheduling. One favor to ask is that at the very end of our presentation, we'll have a Q&A session. So please write all your questions in the chat. So I hope we'll have time to answer all of them at the very end, as I mentioned. Okay, so in-node scheduling. So we already, most of you already used in-node scheduling as one of the major lighting control strategies in your projects. And we would like to mention a little bit more how we did improve this functionality. Just a second. Okay. So a little bit of background at the very beginning. So most of you already used scheduling in some of your projects, but this was mainly available and only available through the gateway. Installing a gateway in a project has pros and cons. That's why we wanted to improve it. And that's why in-node scheduling came into our roadmap. And that was one of the most important developments during last time. And it was to some extent a really complex functionality. It covered like most of the areas of our functionality. And of course, the main reason why we did it, besides some kind of economic ones to reduce some kind of costs related to installing such a functionality, also we wanted to improve like a simplicity, improve the way how this functionality is installed in a project. So it's really simple and easy for the installer to add it to a project. Also, this is some kind of next step or some kind of extension of the overall Bluetooth mesh architecture, which is a fully decentralized lighting control system. So in here, that's exactly the concept which is also behind in-node scheduling. Paweł will we'll talk a little bit about this later. In terms of target application, we do not limit any applications like lighting applications. We can only say that, and you know it better than us, that there are definitely some projects where installing a gateway is not an option. So for these type of projects, for various reasons, because of internet connectivity, because of costs, or some other reasons, installing a gateway is not possible. And when we've got scheduling available only through the gateway, you cannot use this functionality. So that's why in-node scheduling comes in place. We in the next slides, we've got a couple of product and technical related topics. I will pass over this presentation to Paweł right now, and I will come back at the very end to discuss what's available right now on the market and how to start your very first project.
Thanks, Bartek. Hello, everyone. Thanks for joining us. I'm really happy to talk with you about our in-node scheduling. So I would talk about some product perspective and give you also some technical perspective on how this scheduling, how this feature works. So let's start with an overview of the most important features of this in-node scheduling. As usual, we designed and implemented this in-node scheduling with the approach of no single point of failure, continuing this approach that we're using our lighting control based on Bluetooth mesh. We also wanted to minimize the required effort that is needed to implement this kind of control. So no additional hardware and minimum effort required in projects using in-node scheduling. This is also why the in-node scheduling is operating in local time. It's one of the lessons learned from the gateway scheduling, which currently operates in universal time. And we also wanted and added the known and loved scene recall capabilities that is available also in gateway scheduling that allows triggering light control behavior change, so that we can, by using the time-based events, we can change occupancy, we can change lighting control to occupancy sensing, to daylight harvesting, or fixed light level control. Two of the remaining key features will give you some peace of mind, that is the persistence of time and the events of power outage. And we also with this 2.20 firmware, we also introduced a support for real-time clock that is also providing to better accuracy of the timekeeping. So what is required to have this in-node scheduling in the projects? First of all, it is important to be aware of that the project requires all nodes having running firmware 2.20. It's for the reasons I will talk about in details later in the presentation, but I just wanted to highlight that this is important, that all nodes or devices in the network have this 2.20 firmware or above. What's also needed is a new created project or project already created project updated to the version 2021-01. What is the third? I would say a critical thing is also to have a project level connectivity, which is also a fundamental requirement for Bluetooth mesh lighting networks, but it also applies specifically to in-node scheduling due to the fact that we need to have a proper time propagation in the network. So let's go through some few simple steps or stages of commissioning the in-node scheduling in the project. First of all, I think that it is important to definitely properly specify the project with that would need to have a in-node scheduling. That is, this is what I've said before. That is to specify project with devices having 2.20 or above firmware version, and to consider as soon as possible proper connectivity. But from a let's say commissioning point of view, we have three stages. First is of course, planning stage. This is the offsite stage. We can create a project create zones as usual, but we need to create a scheduling-based, so multiple scenes / scheduling-based scenario. Define scenes according to the needs of the project, and then create scheduling events. I will go briefly through this project in a short, let's say, hands-on demonstration. Then, when this is ready, we can move to the implementation, the on-site commissioning phase using the mobile app. And here it's business as usual. That is, we just need to add devices to the project, to this particular zones, and the configuration that we define in the web application is going to be applied automatically. What would also happen during the commissioning phase? On-site commissioning phase is the time would be injected and synchronized with the mesh network. We also encourage you to verify the mesh quality, the mesh network quality using mesh quality test feature available in the mobile app. As a third stage, let's call it maintenance. There may be also some situations where using the mobile app would need to be necessary. That is currently, because our current solution does not support automatic daylight savings adjustment 2 times a year. It would be needed to use the mobile app and time sync feature on site to synchronize the time in the network and adjust it to the daylight savings time. Of course, if you would encounter some time drift, the time sync can be also used to synchronize the time and offset this time drift. Also in some power outage situations that I will discuss later on, it would be also required to use the mobile app on site. Okay, so I would like to show you briefly how to apply the in-node scheduling events in your project using the web application, because this is the part where it is currently required to do so. So we can create project as usual. Let's call it scheduling, and we need to select one of the time zones, local time zones, or of where the building is actually is. So we are in Central European time, so we can select UTC +1, and I will leave the location right now empty. So we have created a scheduling project. As usual, we can create an area, upload a floor plan, and then we need to create, as usual, zones. So let's create a zone. Let's, for example, conference room, where we'd like to have and apply the in-node scheduling. So we can select one of the profiles as usual that is predefined profiles that are created with scheduling scenario, or we can create a new one. Let's call it, for example, office scheduling. So we need to select a multiple scene / scheduling scenario here. And for all of you familiar with the gateway scheduling, it's similar. So we are able to create 4 scenes that can run a different, let's say, lighting control behavior. For example, operating hours with, let's say, occupancy sensing, automatic scene, and let's say the second one off. Let it have it be and fixed light level scene with the light switched off. So we can save the profile, and of course we can use it in and other zones. So when we use this profile, the same scenes would be there applied, and the same events would be also applied. I will create, let's say, corridor zone with some kind of different scenario, just to show you the difference between the zones with the scheduling and different scenarios. So when we have appropriate profiles based on multiple scene scenario, define scenes, and so we can have up to 4 scenes that can be triggered in a particular zone. We need to move to the scheduling tab and create events. In order to create scheduling event on those platforms that have the gateway scheduling also available, we need to select in-node scheduling. There is some short description of what is different, what's the difference between those two events, and as we can call it, let's say, operating hours, and select scene from this profile. So we have this profile of office scheduling that have operating hours of 2 additional scenes. And we also can see on the floor plan highlighted zones that would be affected by this particular scheduling event. So let's select operating hours that would be triggered on the weekdays with some kind of fade time at, let's say, 7 a.m. Here we can see that this time, which is different from the gateway scheduling, this time is in the selected time zone. This time zone selected during creating the project, that can be also adjusted with the project settings. So we can save the event, and we can see by hovering this element here on the list, we can see the zones apply that this particular scenario, this particular scheduling event is going to be applied. Of course, we can create additional scheduling events, let's say night with the scene off, that would be applied every weekday, let's say at 8 p.m. of a local time. So currently we have 2 events that are going to be applied in those zones. We can have up to 16 events per zone. Per zone, that means per those zones that have this particular profiles. If we want to have different schedules, we need to create additional profiles and apply it to the zones where we would like to have separate scheduling. Okay. So if we have this planning phase done, we can move to the implementation phase using mobile app. I'm not going to show it to you right now, but I'm confident that you are familiar with it. So that is just adding devices, and during this on-site commissioning, the configuration that is defined in the web application will be applied. Okay, so we went through the process of how to set up the in-node scheduling. Now I would like to discuss some technical details of how this in-node scheduling works in our solution. So here we have 2 topics. One is the configuration and execution of scheduling events, and the second is time synchronization and time propagation in the network. So let's start with the time synchronization. Scheduling events operate on the time based on the time available in the network. And in order to have consistent time in the network, during the commissioning, the mobile app selects the best device as the time authority. Time authority is a device that is keeping the time, and it is propagating the time to all nodes in the network through relays. And the time is published by the time authority every minute. The time that the app uses to synchronize the time with the time authority is based on the time zone selected in the web application while creating a project. So let's imagine that it's 2 p.m. So we're adding on-site and adding devices to the zones. So mobile app is adding devices and just identifying those devices which have the best accuracy of timekeeping, and then this particular device is selected to be a time authority. When the time authority is added, it propagates the time through relays to all nodes in the network. This is why I'm coming back to the thing I've said at the beginning, that we need to have a proper connectivity in the network in order to have the time synchronized in the whole project. On this diagram, this image, I wanted to show you two devices. One device is highlighted in green here. This is a device that is in range of at least one relay, and this device have the time synchronized. And on the left, you can see the red highlighted in red device, which is not in the range of at least one relay. And this device will have a time desynchronized. So the scheduling events here, configured scheduling events, will be triggered probably in different time than the rest of the project. What I also wanted to highlight here is that time is subject to a slight drift due to the hardware-related inaccuracies. And for let's say regular devices running on a Nordic chip, it's around 2 minutes per month. If we're talking about the accuracy of the time-based control, as I mentioned, we introduced in the firmware 2.20 the support for the real-time clock that can provide higher time accuracy, and the difference between the devices or the project with a real-time clock and without is that the time drift in the real-time clock would be around 30 seconds per month versus 2 minutes per month with the projects without the real-time clock. What is also the second benefit of having a real-time clock device is that the time or the persistence of scheduling in the case of network-wide power outage. So when we have a power failure at the level of the whole building or the whole network, the time can be maintained by the real-time clock during that time. What is also important is that even if having a real-time clock is recommended by us, it is not required, so it is optional, and you can build your projects without the real-time clock devices now. What is also I want to highlight is that because the mobile app automatically detects the best candidate for being the time authority, so the device that keeps the time, propagates the time in the network, we need to have only one real-time clock device per project, because the app will automatically detect it and selects it and configures it as a time authority. With the real-time clock feature comes some hardware requirements. The real-time clock is supported only with our UART firmware, so the firmware for the dual chip architecture. So in order to have or build this device, you need to have dual chip architecture, and also we have two requirements. One of them is to incorporate real-time clock module with the accuracy higher than 10 ppms and a battery backup that can hold the time for at least 24 hours. Shortly about the power outage or power failure that is related to the battery backup and the real-time clock. I wanted to shortly talk about this situation that may happen in your project. So we have two types of events. One of the events is a partial power outage. So the power failure that would happen only on the section of the project, for example, zone and few zones, or more one area, but the rest of the network would be still powered on. So in this case, we implemented a procedure called that we call time recovery. So after those devices will come back, let's say online, they will be able to recover the time from other nodes in the network. This also applies to a time authority device. So even if the time authority device would be out of the power and would be not available in the network for some time, when it comes back, it can recover the time from other nodes in the network. The different thing is a network-wide power outage. So when all of the devices in the network will not be powered on, then there are two approaches. One of the approaches, the real-time clock device that have a battery backup, so it can keep the time, for example, for 24 hours. So after the power is on, the time would be still available. The accurate time would be still available for the time authority, which would be the real-time clock, and it can propagate this accurate time to the network. In project where there is no real-time clock, or the outage is longer than the battery backup, we need to synchronize time after the power outage with the network using the time sync feature that is available in the mobile app. And so someone needs to be on site using the mobile app to synchronize the time. What is also I would like to share with you is that this time sync feature can be also used to troubleshoot some issues, or check what's the difference between the project local time and time and devices in the network that would be presented here, because the app would collect or read the time from the time authority. What is also available here is that we can see and we can check when was the last successful time sync using the mobile app. Okay. So we've covered more or less the time synchronization, time propagation, maintaining the time, and power outages topics. So now I would like to talk about what happens when the appropriate time comes, how the scheduling is executed. I've mentioned it before that the scheduling events and the profiles are configured into individual nodes. So each individual node running the scheduling have the appropriate configuration of scenes, the configuration of events, and of course each individual node tracks the time and synchronize the time with the network. Because of this decentralized approach, each device executes their events individually. So each device tracks the time, and when the time is to execute particular events, each individual node just executes the events individually. So if we have, let's say, devices that are, let's say, that fails, maybe even a timeout authority, the scheduling still would be happening on individual nodes, because there is no a central node triggering the scheduling events in the network. Of course, because this scheduling is run by individual nodes and using the configuration, any adjustments to the scheduling needs to be done on site via the mobile app. What is also important, I would say, to keep in mind is that currently, which is also similar to the scheduling, to the gateway scheduling, and those of you who use gateway scheduling are familiar with that of course, manual control right now overrides the scheduling controls, but also the scheduling, unfortunately right now overrides also the manual control. So if we have a manual control and scheduling in the same zone, and we use for example wall switch to override the current lighting control, when the scheduling event comes, it will override the scheduling event in the scheduling control. And this is something that we would like to improve during next developments, improvements in the node scheduling. For all of you that are familiar with gateway scheduling or using a gateway scheduling in your projects, we wanted also to highlight some basic differences between those two approaches. Of course, gateway scheduling requires installing a gateway and connecting it to the internet, but in node scheduling, as a, let's say, standalone approach, doesn't require any additional hardware except for the optional real-time clock. With the in-node scheduling, all nodes in the network needs to have firmware 2.20 or above. That is because the previous versions of the firmware does not have ability to track the time or synchronize or relay the time. So in order to have a proper propagation synchronization of the time in the network, we need to have all of those devices running 2.20 firmware. The in-node scheduling run events on using the local time. It is subject to time drift, as I mentioned before, and in-node scheduling currently does not support astronomical clock, which is currently available only in our gateway scheduling. Adjusting schedules and adjusting the schedules to daylight savings time needs to be done on site using the mobile app, while the gateway scheduling can be adjusted remotely. Yeah, I wanted to also talk shortly about a few things we would like to improve in our future development. One of the things is the automatic adjustment to daylight savings time, so that it would not be required to go and to be on site and use a mobile app in order to adjust the daylight savings time. We want to adjust the interaction between the scheduling and manual control. So adjust the control hierarchy here, so that even if the manual control would override the scheduling would not override manual control, or it would override, but just after some defined time, or when the zone is vacant. We would also like to improve or add the astronomical clock control and holiday exceptions, which I know are some of the features that some of you are waiting for as well. As usual, we would like to, we're looking forward to your feedback. So please use use the in-node scheduling, test it, and if you have any requests, feedback, or you would like to have it working somewhat differently, just let us know. We'll be happy to discuss and improve it on the later development. As usual, we would like to support you with your projects and implementing in-node scheduling and your future projects. So as usual, we have some supporting materials, including a documentation available in our knowledge base and on our website. Please also check our YouTube channel, where currently we have, I believe, one 10-minute video tutorial on how to set up the in-node scheduling. But if you would need some other documentation or some other information, please let us know. I want to highlight also some features that you can use in order to support or troubleshoot any troubleshoot projects using in-node scheduling. First of all, there is a mesh quality test available in the mobile app that I really encourage you to use, or encourage commissioning engineers or people doing the on-site commissioning to use to confirm or verify the quality of the mesh network, as it is really required to have a proper, I would say 100% mesh quality in order to have a proper and quality in-node scheduling. There is this time sync screen in the mobile app, where you can check what's the current time in the network, when it has been synchronized last time, and how it relates to the project local time. Please also be aware of using the scheduling, the details about the scheduling available in the web app. So where these particular zones are configured to use a scheduling, what are the scenes and profiles, and some other information are also available with the commissioning report that is available in the web app to be downloaded, where you can also check as well the version firmware of the devices that are commissioned to the project, because there might be also as I said, there's a requirement to have all devices running 2.20 firmware in the project. As usual, Silvair, as our support team, would be happy to help you in issues and troubleshooting, or in even also in understanding how this scheduling works. So if you have any questions, or you need some support, just let us know, and our support team, our product team, your business representatives are definitely happy to help you. Okay, that's all from me. I will pass right now the presentation to Bartek, and he will share with you some market perspective related to this node scheduling. Okay, the floor is yours.
Thank you, Paweł. That was really informative. Okay, I would like to present a couple of important information here. One of the most important things that I wanted to mention is that you can start your very first project with in-node scheduling like right away. The only thing that is required is an update to the firmware version 2.20 of your existing components. Nothing else is required. So under the constraints that that Paweł has mentioned before, you can start your project with in-node scheduling with your existing hardware right now. When it comes to updating to version 2.20, typically you need to follow a simple steps to update these devices. I will mention it in a second when I will discuss a full overview of different components and components at different stage in the sales channel. Still, you can use your existing components. You don't have to wait for optional RTC, like a real-time clock device, because it requires additional development. Once we released 2.20, we know that several of our partners have already started this development. So somewhere early next year, first components should be commercially available on the market. So this will definitely improve quality or the drift in terms of the time accuracy, but this doesn't limit you from using it even today, because we think that the already existing accuracy or drift without RTC is definitely acceptable and fine enough for majority of the projects. So a couple of things worth mentioning about marketing perspective. So what we did already was so-called like a silent launch or release to our partners. We did it in October, so just recently. At this date, we released also a documentation, some FAQs, video that Paweł mentioned, and today's webinar is also part of this marketing activity that was focused on spreading information across our partners about in-node scheduling. The very next step around it is some kind of wider launch and inform and communicate about this functionality to the market. We plan to do it early next year. And we've got already some activities planned around it, like press releases, of issuing some articles, some emails, and of course case studies. And that's why I come to 2 specific points where I will ask for your help in here, or probably you would like to proactively join our marketing activities. So if you would like to take part in any of our marketing activities, just let us know. We are happy to cooperate to get deeper into the market and get like a wider adoption of this feature across different geographies. So let us know if you would like to be part of any sort of marketing activities, and as well if you would like to do any case studies, or you know that you've got in your pipeline a project that requires scheduling, and probably in-node scheduling would be the best option right now. We would be happy to join and help you with collecting some information from this project, and then build together a case study and promote it as a very first project with in-node scheduling. So if you're willing to be part of it, let us know as well. We are looking forward to working with you on it. As I mentioned before, just a summary of to make it clear how to move forward with in-node scheduling for your already existing components or new components that are already somewhere in the sales channel, or in stock at some warehouses, or you plan to order some additional components. So a couple of things worth mentioning. First of all, as I mentioned, the very like to start, you might have a situation where some facility manager or somebody who owns a project that you've installed already based on Bluetooth Mesh, they request to extend it with scheduling. Probably in-node scheduling will be the best option here. So over-the-air update will be the only option, or the only reasonable option to get this functionality up and running. So in this particular case, for this type of components at this stage of life cycle of this component, what action is required is to confirm with the component manufacturer that over-the-air update is available until the version 2.20. And of course, after that, what is also important, you need to first of all update these devices on site up to 2.20 firmware version, then remove all the devices from the project, update the project through the web app to the newest version, and then re-add or recommission these devices to the project, to the zones how it was before, and set it up like accordingly to the specification. So that's what how an existing project or components that are already in the ceiling can be extended with in-node scheduling. Still, second example or second case is where the components are somewhere in the sales channels where they left already in the manufacturing side. So they were already manufactured and sent out either to a luminaire OEM or somewhere further to the project side, but haven't been installed yet. So that's, I would say, a very long long chain here. So we think that 2 options might be reasonable here. First, as I mentioned before, over-the-air update might be an option. And additionally, reflashing these devices using Mate might be also an option. Still, the question is how you can access these devices and whether it is possible to access these devices, and what are the costs related to performing this action. So when it comes to over-the-air update, you need to check exactly the same things as before. So make sure that over-the-air update is available for these devices up to 2.20. And when it comes to reflashing, make sure, of course, that reflashing makes sense, that it is possible. And of course, you need to request 2.20 version of the firmware for these particular devices. And if a manufacturer is in, like a component manufacturer is in charge of these devices, they need to still request, first of all, our development order ID to check whether everything works properly. Then after performing some tests, request production version of our firmware, so they can be reflashed with this production version of the firmware. That's our typical, nothing unusual. This is our typical way of switching to the newer version of the firmware for a particular devices when it comes to component manufacturers. The third option, if you plan to issue any POs, or you issued already some POs, but you haven't received them, they are not manufactured yet, they are not flashed yet, please keep in mind that you might request them specifically with the firmware version 2.20, which means that you can get in-node scheduling right away with these devices already included because of the version of the firmware. As I mentioned before, the version of the firmware, when it comes to manufacturing, it needs to be requested per our standard process when switching to the newer version of the firmware. And last but not least, I mentioned it before, just wanted to highlight one very important thing, that components that are in development right now with real-time clock, there will be a couple of them somewhere early next year. That's our best guess right now. But if anybody would like to build their own component, we are happy to help you with it. You need to request 2.20 version of the firmware and use documentation that is available in the knowledge base per Pavel's information on earlier slide. If you don't want to develop on a real-time clock device, but you would like to use it, we can also streamline the overall process by introducing you directly to a component manufacturer who will have this component available and is right now in development. So let us know directly whether you have any request like this. We will be happy to help you. That's the very last slide about in-node scheduling. Right now, it's time for the question part. And we already received a couple of questions before. We've got just a couple of minutes left until the time finishes planned for today's webinar. So we can start with answering the questions that we received before this webinar. And then if we will have still time, we can answer some questions that we received through the chat from you during this session.
Okay, maybe I'll do it. As Bartek mentioned, we received some questions before the presentation, and we have 5 minutes, so I don't think we will. And we've got also a lot of questions today during this webinar, so we will try to answer some of those questions. To those questions that we won't have time, we will reply or answer you directly, or maybe we'll add it to the FAQ. I will definitely will get the answers. If you have any questions also after the webinar, just let us know. It can be through support, through ticket, or directly to your business representative. Or so yeah. Okay, so let's start with the first question. I think it will also answer some of the questions reflected on the chat. So, is it possible to use in-node scheduling only in a part of the project? Basically, yes, it is possible. Of course, we need to be aware, or you need to be aware that the whole project needs to run 2.20 firmware. So the devices or the project needs to be updated or just created, commissioned with this firmware. And as I mentioned before, the connectivity needs to be provided and verified. The second question is, it is possible to have in-node scheduling and a gateway scheduling in the same project. So yes, it is possible. Both options are available in a single project. Just while creating a scheduling event, you need to select the appropriate type of the event to be executed in particular zone. We have also questions similar. I would like to check if I answered this question. If this answer answers also those questions. So we have a project with several zones managed by a gateway. Can we still have one zone managed by an in-node or on a separate schedule scenario? Yes, so it is possible. Just those nodes needs to be able to have 2.20 firmware, and they need to be updated and configured properly. So have a profile and in-node scheduling events. It is possible to add the in-node scheduling to existing project that has a gateway or a photo sensor control in other zones. Yes, it is possible. You need to update the firmware and the project version and apply this in-node scheduling. I don't know. I'm not sure if Bartek mentioned it, but for the devices running previous version of the firmware, after the over-the-air update, those devices need to be removed and added again to the project. So this is a recommission in order to activate those new features. This also relates to one of the remaining question, and I believe this would be the last one. What is the recommended process for adding scheduling to a project running on 2.19 firmware? So as I mentioned, currently we need to update all of those devices to 2.20 firmware. They need to be available for those devices, and then we need to remove those devices and add those devices again in order to activate those features. Currently, any upcoming over-the-air update features that would be available with the mesh, next versions of the mesh, Bluetooth mesh, are currently not available. Okay, the questions, we are running out of time, so I think that we will get back to you to answer your questions. And just
Yeah, and probably
thanks.
just one very final information from my side. We'll be this is our very first webinar in this forum. We would like to continue this formula. That's why we will ask you for some kind of feedback. What do you think? What do you like? What went good? What went a little bit less? We are looking forward to hearing your feedback about today's session, and we look forward to the next sessions as well. So thank you very much for today's attendance, and we, as Pavel mentioned, we will come back to you with answers to the questions that we received from you, and if you have any further questions, let us know through your channels or communication channels that are already set up. So thank you very much for today. Thank you very much, Pavel, for driving this session, and hope to see you in future.
Thanks, Bartek, and thanks all of you for joining us today. Have a good day or evening.